In this video, I'm going to be showing a red-black tree's rotation. And here is the algorithm that we're going to be looking at, the insert fix-up algorithm. So we can see here that I've created a AVL tree, which was a perfectly fine red-black tree until I added this node, inserted this node into the tree, and now it is not a red-black tree, as it's breaking one of the rules, which is if a node is red, then both its children are black. So we can see that's being broken here, so we need to run this insert fix-up algorithm. So we can see here we've got the node, we've got the node's parent, the grandparent, and the uncle. We'll go through the code, and if the node's parent equal is the parent is the left of the grandparent, make the uncle the right. And then if the uncle's color is red, so this is when we're going to run this block of code because the uncle's color is red here. So we're going to go through and change some of the colors. So we're going to change the parent to black. We're going to change the uncle to black. And we're also going to try and change the grandparent to red. And then we're going to come to this line, which is where we're now making the grandparent the node that we're going to be focusing on and working on. So let's do that. And we're going to loop back, and we're going to go back to the start of the while loop, and we're going to check again. While the node's parent is red, which it still is, we will run again. This time the uncle isn't red, so we can skip this block of code and go straight to this conditions statement. And if the node equals is the right child of its parent, okay, it is, then we will make the node, so we'll make the parent node the node that we're going to work on. Let's do that. Now we'll perform the left rotation on this node. So the first step is to make the right child is as the X. The left child of the X should now point to be the right child of the node. So let's do that. Let's change that pointer. That's that line. If X left is not none, well, it is none, so we can skip that. So the X's parent should now be the same as the node's parent. Let's change that pointer to make it a parent of the. If node's parent equals none, that doesn't apply. Else if the node equals the left child, yes. The node is the left child of the parent, so therefore X now becomes the new left child of the parent. So if we update that and pull that around, we can see that X has become, so the X has become the child of the root node here, and to the left of X is our node, initial node that we're working with. Changing the pointer to make that the X the parent, we now need to color the node parent black and the node's grandparent red. And this still creates an issue, so this isn't finished because, well, it's still not a red-black tree because you cannot have the root node as red. So now we're going to perform the right rotation on the grandparent node. So we're going to make the node that we're working on the root node up here. So, and the Y is going to be the left child of the root node. Okay, so let's go through and go the right child of y equals the left child of the node. So we're going to change that pointer to point to be a child of our node. If y, y's right child is not none, it is none, so we can skip that. The y parent equals the nodes. Y's parent equals the node's parent. Look, we'll skip that. If the node parent equals none, which that's true, it equals none, then the tree root equals y. So this y now is going to become the root of the tree. And the y right equals node. So let's go through. So the node now becomes the right child of the y node, and everything else then falls into line here, and we can see it's now a legitimate red-black tree. It's following all the rules and it's very well balanced. And that's how the left rotation works. The right rotation is basically the same thing, but everything's the opposite of that. And that's it. Thank you for watching.